This is the Seagate Mach.2, the fastest hard drive on the market. It can read and write at speeds of over 400 megabytes per second using a dual actuator technology, one of the biggest advancements in hard drive technology for over a decade. But it's had a really interesting history. In the news, it's pretty much only been Seagate announcements. They first demoed the technology in 2017, said it was shipping in 2021, and there's still almost no info out it, and I can find almost no one else with information of this drive. It popped up on eBay, so I wanted to see what this thing was, run some tests, and actually play with a real version of this drive. So what is this dual actuator technology doing? In a single actuator drive like this one here, there's one actuator that moves the heads to any position on the disks, but it can only read and write from one of these heads at any time. Modern hard drives have been adding more and more platters to get more data on these drives. But since only one head can be read or written from at any given time, adding more platters doesn't improve performance. Here's a little interesting graph of how long it takes to read all the data on a drive. And with modern drives getting bigger, they are a bit faster than older drives, but the time it takes to read all of the data has also gone way up. And this means things like RAID rebuilds have gotten much longer in recent times, making your data harder to recover in that sort of situation. And it also means with applications that have some sorts of reads, it's almost impractical to use a very large drive because it just isn't fast enough for those applications. So the multiple actuator technology essentially stacks another set of platters on here with its own actuator, and they operate completely independently of each other, both able to read their own set of data at once and transmit it to the host. It's almost like having two hard drives crammed together, but only having one motor instead of two and taking up the space of one drive. And this drive really seems like there's been two hard drives stuffed in here. Looking at the circuit board, it looks like there's two controller chips with two DRAM chips, double that of a normal hard drive. And when you plug this into your computer, it shows up as two 7 terabyte drives, not one 14 terabyte drive. And it's up to you as a user to determine how those 7 terabyte drives should be allocated. Testing performance on this drive can be a little bit difficult because it's two drives. If I test the performance on one half of this drive, it performs just like a modern hard drive. Here's some Crystal Disk Mark results, and all the performance of this drive is just about what you'd expect out of a modern hard drive. And there's another half that performs exactly the same. But when used together, I can run them in RAID 0 and get this combined speed, which seems like a lot less than you should get in RAID 0. So I did a lot of messing around with this system. I tried it on another computer that I had, but both had older SAS 6 gigabit per second connections. I couldn't find an exact reason of why I was getting only a bit over 400 megabytes per second instead of over 500 megabytes per second that would make sense, but I'm guessing it's some weird SAS anomaly. And thinking about SAS anomalies, this guy had a couple. I couldn't find a way to use those little SAS cables that plug into like an HBA directly. I had to use a server with a SAS backplane, and it would work fine. One of my thoughts was it was using the second set of pins on a SAS drive, as there was a second route of data to many SAS drives so they can be used with two hosts at the same time. I put some tape over that connector, and it looks like this one pin is doing everything. Also, I tried this with a RAID controller once just to see how it worked, and the RAID controller only recognized one 7 terabyte part of this drive and not the second 7 terabyte part. I'm probably not using the exact recommended technology, but this has definitely been a weirder drive when it comes to using it compared to any of the other SAS or SATA drives that I have worked with. I also read the smart data of the drive, or the self-reported health of the drive. Both halves can have those smart data read, and it looks like it's identical data on both halves. Reading the smart data of this drive made me have even more questions about the past of this drive. The smart data had been wiped with very low hours and data read and written when I got it, and it also said it was manufactured in the 47th week of 2022. But looking on the sticker of this drive, it said it was manufactured in December of 2021. Weird there's such a large date difference between it. And this is also a recertified product with a Seagate sticker on it though, and a little bit of a marking on the bottom of the drive too. I tried putting the serial number in Seagate's warranty checker and it says contact your OEM, we don't warranty this drive. So I have no idea about the history of this drive. I hope this technology finds its way to the consumer market. This hard drive seemed to work pretty well for me. Put the two halves in RAID 0, and it works like almost any other drive, but with nearly double the performance and IOPS compared to a normal drive, which makes a lot of drive operations like backups or NAS use much quicker and there's a lot less hard drive bottlenecks, which I've been running into with many traditional drives. But this drive has only found its way into presumably large data centers. I'm not sure why. Perhaps there's some sort of exclusivity contract, or Seagate sells enough of them to those data centers that they don't even want to bother with retail sales. WD has also announced that they're making similar multi-actuator drives. I hope they also sell them on the consumer market, but it seems like they're targeting the data center market too. Let me know if there's any other tests you want me to run on this drive. This drive has been a massive improvement compared to all the other drive changes I've seen in over the last decade, and I really hope this technology finds its way onto other drives.